Hey guys, Mr. Backerberg here. In this video, we're going to take a look at local and also absolute extrema. Now, as we're looking at the graph of a function, graphs are often made up of different peaks and valleys within our picture. At the lowest point of each valley, we have minimum values. Now, if we're talking about a local minimum, or also called a relative minimum, that's the lowest point on just a small region of our graph. But if we're talking about the absolute minimum, then that's the lowest point on the entire graph. Now, we can also have maximum values. And maximum values would happen at the top of the peak of a graph. And again, there can be a local maximum on just a short region, a small region of our graph. Or we could have an absolute maximum, which would be the highest point on the entire graph. We're going to take a look at an example of identifying some different local extrema, so local maximums and local minimums. We're going to look at the function f of x equals x to the fourth minus 3x squared plus 2x. And we're going to look at this picture on our calculator. So I've already got my function typed in. I'm going to hit the graph button and we'll get a picture that looks something like this. Now we're looking for any local maximum and local minimum values. So local minimum values are going to happen at the bottoms of these two valleys that we have on our graph. Now we can actually use our calculator to help us find a pretty exact value as to where those maximum and minimums are happening. So what we're going to do is we're going to hit second and then our trace button. And if we look in our options there, 3 and 4 give us an option for finding a minimum and a maximum value. So I'm going to start with number 3. I'm going to start with a minimum. Now what it wants is a left bound point. So if I'm focusing on this minimum at the bottom of this bigger valley over here, left bound means I want to start on the left hand side of that valley. And I'm going to hit enter. And then a right bound point, we want to arrow over to the right past that valley. And what it's going to do is it's going to look between these two lines that it puts on my graph for the lowest point. Now we can take a guess, but it's not 100% necessary, so maybe our minimum is about right there. I'll hit enter, and then it'll tell me where my minimum value is. So this ordered pair, this x and y value, is the minimum of that graph. Now there is also another minimum happening up here, so we can find that one by doing the same thing. So going second, trace, and picking option number 3, minimum again. So now we want to arrow over by that other minimum. And again, we want a left bound point, so I'm going to hit left a couple times, hit enter. Then I'm going to go to the right past that value and hit enter. We can take a guess, but we don't have to. We can just hit enter one more time. So there's our relative minimum there. Now, as you look at your y value, you're going to see some stuff that looks like scientific notation. So what we've got is 2.2 times 10 to the negative 12. What we need to be able to recognize is that times 10 to the negative 12 really means a left slide with our decimal point 12 spaces. So we'd get a decimal with a big long string of zeros leading it off. So really we can just approximate that value at 0. So really this minimum is happening at the point 1, 0. Now we can also use this process to find our relative maximum in here as well at the top of this peak. So I'm going to hit second, trace, but this time I'm going to pick option number 4, maximum. Just like we were doing before, when it asks you for a left bound point, we need to be to the left of where we think that maximum is happening. And then arrow over to the right past where that maximum is happening. And again, we can take a guess, but we don't need to. We can just hit enter, and it'll give us an ordered pair for that relative maximum at the top of that peak. That's going to be it for this video. Thanks for watching.